Across the plains of southern Africa, scattered among riverbeds and ancient terraces, lie stones shaped by human hands nearly 500,000 years ago. These were not random rocks. They were the first expressions of thought, planning, and design. They belonged to what archaeologists call the Fauresmith culture, a transitional phase between the Acheulean hand axe makers and the earliest representatives of our own species, Homo sapiens. Their tools reveal more than survival. They reveal the birth of human ingenuity itself. This film explores how that same inventive spark still drives the tools, technologies, and digital creations we use every day. When most people imagine prehistory, they picture crude stone implements and brute survival. Yet the Fauresmith industry tells a different story, one of sophistication and subtlety. Its artifacts, found mainly in South Africa, Botswana, and Namibia, date roughly from 400,000 to 250,000 years ago. They show the gradual replacement of heavy, teardrop-shaped Acheulean hand axes with smaller, finely flaked points and blades produced by striking prepared stone cores. This innovation, known as the Livawa technique, required abstract reasoning, a mental template of the finished tool before it was made. It marks a turning point in cognitive evolution. Humans had begun to plan ahead. Toolmaking was not simply mechanical, it was intellectual. Imagine holding a lump of rock, visualizing its inner layers, and striking it just hard enough, but not too hard to remove flakes in a predictable pattern. This precision represents a form of early engineering. Each flake removed followed a sequence of angles and pressures, controlled by experience and anticipation. To call these toolmakers primitive is to ignore the evidence of design thinking visible in every strike scar. The genesis of ingenuity lies in this moment, when observation turned into modification, and modification into mastery. With rock, bone, and wood, early humans learned that materials had properties, density, elasticity, fracture points, and that those properties could be exploited. A rounded stone became a hammer, sharpened edge became a knife, a split stick became a spear shaft. Each discovery was an aha moment, a triumph of experimentation that foreshadowed science itself. Through their tools, the Fauresmith people demonstrated that intelligence is not defined by language or art alone, but by the ability to solve problems creatively. What began as survival quickly became design. The shape of a cutting edge, the angle of a grip, the polish from repetitive use, all speak to ergonomics long before the term existed. A good tool fit the hand, reduced effort, and produced consistent results. Even the choice of raw materials shows selectivity: fine-grained quartzite or chert for sharper edges, tougher basalt for pounding. In essence, these early artisans were performing the same evaluations modern engineers perform in materials science labs today. If we look closely at the objects around us, knives, hammers, needles, we find echoes of those ancient designs. The modern kitchen knife follows the same geometry as a flaked stone blade, a wedge that concentrates force along a thin edge. A hammer's balance mirrors that of a handheld pounding stone, optimized through countless generations of trial. A sewing needle, descended from bone awls used to pierce hides, transforms the same principle of focused pressure into textile craft. Every time we turn a screwdriver or click a pen, we reenact movements refined by our ancestors hundreds of millennia ago. The principles of design that guided the Fauresmith toolmakers' leverage, sharpness, friction, symmetry, remain the foundation of modern technology. Consider leverage, the simple act of using one object to amplify force. Lever is merely a stick with a pivot, yet it underpins cranes, scissors, and robotic arms. Sharpness, too, is universal, whether in obsidian flakes, surgical scalpels, or laser beams. The goal is identical: concentrate energy to divide matter efficiently. And friction, once controlled by stone polishers smoothing tool edges, now governs engines, tires, and hard drive heads. The continuity is astonishing. Our modern world of objects is thus an inheritance from the Stone Age. A smartphone's sleek casing conceals centuries of tool evolution, from carving to casting to machining to microfabrication. Even its touchscreen, sensing the pressure and movement of human fingers, echoes the tactile intelligence that first guided a stone chipper's hand. We have not escaped our origins. We have refined them. Over time, necessity gave birth to specialization. Early humans once relied on a few multi-purpose tools, one stone for many tasks. But as populations grew and resources diversified, efficiency demanded new forms. Axes became ADSs for woodworking. Scrapers became knives. Hammerstones evolved into anvils. The leap from general use to specialized function transformed not only technology but society itself. Specialized toolmakers emerged, sharing their skills through teaching and trade. The first economies were built not on currency, but on craftsmanship. As communities settled, specialization fostered collaboration. A skilled flint knapper might exchange blades for food or shelter, much like a modern craftsman trades expertise for income. This exchange created social bonds and encouraged innovation. People could rely on others for certain goods; they were free to invent new ones. Thus, the evolution of tools fueled the growth of agriculture, architecture, and urban life. Each advance rested upon earlier experiments in shaping and joining materials, from grinding grain to building walls. Archaeologists trace these transitions through time, linking the Fauresmith to later industries such as the Still Bay and Howson's Port. In each we see growing refinement: heat-treated stone, hafted blades, composite tools. But the underlying logic remains constant: humans using knowledge of form and function to extend their physical abilities. A hand axe was an extension of the arm. A spear extended reach. Later, the plow extended energy from animal muscle. Technology in every era has been the art of extension. Fast forward to the present, and the same principle defines the digital age. Where our ancestors chipped stones, we now manipulate data. The gestures are abstract, but the cognitive process is identical. Visualize, plan, execute, refine. A programmer shaping code follows a sequence much like a toolmaker shaping flint, removing what's unnecessary, perfecting what remains. Both disciplines demand logic, patience, and pattern recognition. In this sense, the logic of toolmaking evolved into the logic of coding. Early humans learned through iteration. Strike, test, adjust. Software developers do the same through debugging and optimization. Each tool, whether a stone scraper or a line of code, is a human attempt to make the world more efficient. Our neural wiring for problem solving was forged by tool use. Brain imaging studies show overlapping regions activated when people grasp physical tools and when they plan abstract tasks. We are, by biology, tool thinkers. The Fauresmith legacy therefore extends far beyond archaeology. It shaped the architecture of the human mind. Our capacity for sequential thought, foresight, and imagination all trace back to those ancient hands shaping stone. The leap from flint to silicon was long in years but short in principle. Both embody the desire to store energy and information, to harness natural forces for human purpose. Every innovation, from the first fire starter to quantum computing, is another verse in the same story. Yet in celebrating our progress, we risk forgetting our origins. Understanding the logic of early tools can illuminate paths to a more sustainable future. The Fauresmith toolmakers worked within limits. They used local materials, recycled broken tools, and balanced effort with reward. Their designs were efficient because waste meant survival risk. In contrast, modern production often values speed over sustainability. Revisiting ancient principles of durability and reuse could guide eco-friendly design today. Around the world, a quiet revival of craft is underway. Woodworking, metal forging, pottery, 3D printing, all echoing hands-on creativity. These movements remind us that making with our hands reconnects us to materials, to patience, and to purpose. As automation expands, human creativity becomes more valuable, not less. The same tactile intelligence that guided the Fauresmith artisan can inspire engineers and artists in a high-tech century. Consider the challenge of designing sustainable tools for future space missions or renewable energy systems. The engineers solving these problems are modern counterparts of prehistoric innovators. They too must think with limited resources, adapt to harsh environments, and craft reliable solutions. By studying ancient ingenuity, we learn humility and rediscover principles that transcend time, simplicity, efficiency, and adaptability. Archaeologists working at Fauresmith sites often speak of a strange familiarity, the sense that the minds behind these artifacts were not so different from ours, The flake scars show deliberation. The repeated patterns suggest training and teaching. Some sites even preserve clusters of discarded attempts, evidence of learning through failure. In those fragments, we glimpse the first classrooms of humanity open-air workshops, where knowledge was passed from one generation to the next through demonstration and repetition. Failure, experimentation, refinement, these are the same processes that define modern innovation cycles. In every research lab, design studio, or coding sprint, the pattern persists. The past is not a museum, it is a mirror. To go beyond Fauresmith is not to leave it behind, but to recognize its living presence in our minds and machines. Understanding ancient ingenuity also deepens appreciation for the diversity of human evolution. The Fauresmith industry may have been created by Homo heidelbergensis, or early Homo sapiens. Regardless, it represents shared intelligence across humanity's branching tree. Innovation was never limited to one lineage or region. It was a collective inheritance. This perspective counters the old narrative of linear progress and celebrates multiple centers of creativity across Africa and beyond. In classrooms and digital platforms, connecting these insights to modern education can inspire young learners. Imagine teaching physics or engineering by tracing principles back to ancient tool use, explaining torque through stone hammers, aerodynamics through spear points, or geometry through flake angles. By linking the ancient and the modern, we make science a story of continuity rather than rupture. Students begin to see invention as a natural human trait, not a modern privilege. The story of human innovation is thus circular. We began by shaping stones. Now we shape data. We once chipped away to reveal an edge. Now we code to reveal a function. The substance has changed, but the curiosity remains the same. Every screen we touch, every machine we build, carries the memory of that first deliberate strike that turned chaos into design. In the coming decades, technology will continue to evolve: artificial intelligence, nanofabrication, quantum computing, yet each will still follow the ancient template. Define a problem, imagine a tool, test, and refine. Recognizing this lineage grounds progress in humility. We are not separate from our ancestors. We're their continuation. The future forged in the past calls for balance. As we automate creation, we must preserve creativity. As we digitize communication, we must remember connection. Hands-on craftsmanship, whether in art or engineering, remains vital for understanding how things work. The tactile feedback of shaping material teaches empathy for systems, an awareness easily lost in virtual environments. To build a sustainable future, we must unite ancient intuition with modern intellect. Standing before a display of Fauresmith tools, small, symmetrical, beautifully made, it is impossible not to feel awe. Each flake captures a decision, a spark of thought from a mind like ours, yet separated by hundreds of millennia. Those stones whisper that intelligence is not new, it is inherited. They remind us that progress is not measured only by speed or power, but by the continuity of curiosity. Our ancestors' world was one of limitation, yet within those limits they found endless possibility. Today, surrounded by abundance, we often forget that creativity flourishes under constraint. The Fauresmith toolmaker had no machines, no manuals, only patience, perception, and purpose. Perhaps that is why their legacy endures. It speaks to the essence of being human, to imagine something that does not yet exist and bring it into being with one's own hands. As we look ahead to new technologies and challenges, from sustainable design to artificial intelligence, the lesson is clear. Innovation is not about discarding the past, but building upon it. Every invention, no matter how advanced, begins with the same impulse that moved an early human to shape a stone: the desire to make life better. That impulse unites us across time. The story of Beyond Fauresmith is therefore a celebration of continuity, a reminder that our digital age was born from the dust of ancient workshops. The same neural sparks that guided a flint strike now illuminate computer screens around the world. When we hold a smartphone, we hold the distant echo of a stone blade. When we design a circuit, we follow the same pattern of thought that guided the first toolmaker's hand. By reconnecting with our ancient innovative spirit, we can face the future with wisdom. The Fauresmith people teach us that true progress lies not in replacing the old, but in understanding it. The tools of the past are not relics. They are blueprints for resilience, creativity, and balance. To go beyond Fauresmith is to realize that the line between ancient and modern is an illusion. We are still shaping, still learning, still human.